So we're going to talk about a specific pattern that you can use when you're building AI products called the evaluator-optimizer pattern. So I'm going to explain how it works. I'm going to actually run through some code with you, just show you what I did. And I use this to get the AI to tell funny jokes, so you can judge whether you think the jokes are funny or not. But typically, ChatGPT jokes are not great. You know, they're like dad jokes. And I am a dad, so I appreciate them, but most people don't. And I wanted to use that as an example of a fuzzy evaluation. There's a lot of creative tasks that we're asking AI to do, and it's very, very hard to formally define whether they're doing a good job or not. So this is a really good pattern for that. So who am I? I'm Mike Taylor. So this is an AI-generated headshot for me, you know, keeping. But the book that I wrote last year was Prompt Engineering for Generative AI with James Phoenix, who's unfortunately sick today, but we wrote that book together. It still holds up, thankfully, despite everything happening in AI, because actually prompt engineering, people predicted would be dead by now, because the AI models get smarter and smarter. And it turns out that actually the smarter they get, the more the prompt matters. And you really need to make sure you understand what goes into the context. And now we've rebranded prompt engineering as context engineering because, you know, why not? We want to sound cool. You know, it's largely the same sort of thing, but with a few differences. And I'm going to kind of walk through that as well as we go through. I do have a copy of the book here. And we're going to do questions at the end of both talks. So me and Leo, who's talking next, will stand up here, and then whoever asks the best question will get a free copy. Okay. So I'll use the LLM-as-a-Judge. All right. So what is context engineering? Some of you might have heard about it. Some of you might not have heard about it at all. Others of you are probably sick of it already. You know, it depends. It's all not evenly distributed across the audience. But the quote that I really like, I know Toby Lutke from Shopify has talked about context engineering, and Andrej Karpathy has talked about it as well. But the guy I think who coined it was Ankur Goyal. I think he's at Brain Trust Data, one of the evaluation tools. He said, as the models get more powerful, I find myself focusing more effort on context engineering, which is the task of bringing the right information in the right format to the LLM. So that's, I think, a really good kind of self-explanatory definition. But in order to bring the right information to the LLM at the right time, it's really, really difficult. And you know, the first mistake most people make is they don't give it enough context. They don't give it enough information to actually do the job. They don't give it the sort of information that you would give to an intern on their first day. You know, and I'd say like that's usually pretty easily solvable. Like once you understand that LLMs aren't magic, they need some context. They need to understand how your organization does that task or how your application should do that task. Then usually pretty straightforward to identify, okay, well, the intern would have access to Gmail, you know, the intern would have access to this document, or maybe we need to write up a brief of how to do this task. And that's how I would say like the beginning stages of prompt engineering, context engineering begin, is like when you don't have enough context. But you very quickly enter into the much, much worse problem of too much information. So there's all sorts of crazy things that can happen when you have too much in your context window. And on purpose, I've made this slide stuffed with information so you can experience what it's like to have a full context window. But these are all the different problems that I've seen with my clients and with my own applications that I've been building. Context poisoning, that's when it hallucinates, gives you like a weird answer because there's some you know, incorrect information in the prompt itself, and it's kind of going off of that. And that can happen quite easily, especially when you give tools access to MCPs where they can pull information that you might not necessarily need to do that task. Context distraction, as the prompt gets really, really long, it starts to not pay attention to some parts and pay more attention to others. LLMs are really good at deciding what to pay attention to, but even the best LLMs will still make mistakes. And they tend to pay more attention to the beginning and the end of the prompt, and the stuff in the middle gets lost, so that's the lost in the middle one. There's also context clash. Sometimes you'll have conflicting information, and this happens with interns too. You know, one boss says this, the other boss says this, you know, the official documents say something else, and that happens with LLMs as well. A lot of the problems that we face with building effective AI agents, we also face with just training people as well. Before I got into AI, I used to run a marketing agency, and trust me, it's like exactly the same problems coming up again and again. But this time with AI employees that never sleep, so quite useful. Then you also have problems with like prompt injection. Sometimes you want to control what type of information goes into the LLM, because if it's accessible to the AI agent, then anyone using that system could get that information by tricking it into sharing, oversharing. So that's a whole big topic. But to be honest, like the main reason I don't like having too much information in the prompt is it costs too much money. And AIs are really efficient compared to humans, but once you're doing this and you're running thousands of AI agents, or that AI agent is doing thousands of tasks, the cost adds up. I have a small startup, it's just 2.5 people right now, and the highest paid person on my team is OpenAI, right? Yeah. So cost really becomes important. And then latency as well. For some types of applications where it needs to be real time, the longer the prompt, the longer it takes to get a response, because it has to process that whole thing. Cool, so how do we solve this? DSPy will solve all of your problems. No, I'm not affiliated with DSPy. I really hated the framework when I first encountered it, because there was a lot of publicity when it came out. They said prompt engineering is dead, and as someone who was writing a book on prompt engineering, I was really hoping that it wasn't dead. I didn't take it too personally, though. I did dive into the framework, and once I got through the weird documentation and the kind of overly academic tutorials, I started to realize how powerful it is. And weirdly enough, they designed like the perfect library for context engineering 2 years before context engineering became a term. And Toby Lutke, the co-founder of Shopify, confirmed this as well recently. He said that DSPy is what he uses for context engineering personally. So it's having a bit of a moment now because of that, but I've been messing around with it for a while, and hopefully, like I've moved to doing all of my scripting in DSPy, and even putting some projects into production. So I think it's a good time to learn. But you can do this in any framework. LangChain, I don't want to hate on the other frameworks as well. You can do it without a framework, but the code's just easier for you guys to see, and there's like a less boilerplate to write. Cool. So what is the pattern we're going to do? It's the evaluator-optimizer pattern. I use this for a lot of different things, because a lot of the tasks I'm doing, especially because I came from a marketing background, they're creative tasks. I want you to write a blog post or a social media post. I want you to, read this report and tell me what decision to make. These are creative tasks that are pretty fuzzy. You don't always have a right answer. So one of the nice ways you can solve that problem is you can train a classifier first. So we're going to use the example of telling jokes. We're going to have an AI tell jokes. And the first thing you need to do is to train an audience member AI that can tell whether the joke is funny or not. And it's much easier to build a collection of funny jokes, build a collection of not funny jokes, give funny jokes a 1, give not funny jokes a 0, and then you have a data set pretty quickly where you can train the judge. Once you have the judge, then you can train the real task that you're trying to train. So the LLM call evaluator is trained on the jokes that you think are funny and not funny, but then you're using that as the evaluation metric when you're optimizing your original task, which is telling the joke in the first place. Cool. Okay, so we're going to dive into code here. And there's a lot of it, but we're going to go through. I'm going to zoom in a little bit so you guys can see. Is that good? All right, so don't worry if you don't know how to code. I think most of the room is skewing technical, but just close your eyes if it's scaring you. It's not that scary, I promise. I'm going to explain each step what we're doing. So I'm not going to run any of this, by the way, because DSPy does take like 10 to 30 to maybe even 30 minutes, like an hour sometimes. My longest running optimization was 16 hours, actually, and it cost me $800. So yeah, that was paid for by a client, so don't worry, I didn't get my credit card out. But one of the nice things I like about DSPy is it abstracts away a lot of the complexity of calling AI models and getting the responses back. So this is like how you set up the model. The GPT-5 mini here, and then I just set those parameters, and then I hit call, and then it literally just sends that prompt, right? Super simple. And if I wanted to use Google or whatever, I can put Gemini in here, and then I could change that to whatever model I want to use. If I want to upgrade to a new model, it's literally one line of code, which is really, really nice. It makes the programs more portable, and because there's always new models coming out, and also quite often you want to like move the program down to a cheaper model once you've optimized it, and that's something that DSPy does quite well. Cool. So that's my little pitch. I don't use the standard DSPy structure. If you guys want to see what that looks like, it's like this. Which is weird, and like it took me a long time to get over the weirdness of it, but like this is your prompt, like the doc string, and then these are your inputs for the prompt. So these are the different pieces of context that you're sending it. In this case, this is a classifier. It's going to classify the sentiment of a given sentence, and you're going to pass in the sentence as an input field. The sentiment will be an output field, and it just has these three possible outputs, and then it gives like a confidence score, right? So that's like a DSPy program. I don't use that because I really hate that. So what I do is I found deep in the code base they have this like convenience method called make signature. And it's the same stuff, but I prefer it to kind of, it feels a bit more Pythonic or whatever. So I write my instructions here as a string, and then I pass in the different fields. You can see here the input field and output field. So what this will do is create a prompt for me. I don't have to worry about the instructions other than what I told it. I don't have to write a big long list of instructions. I'm just giving it a small amount of instructions, and it's going to set up things like, here are the structured outputs that we need. It's going to handle output parsing for me, so it's going to pull those outputs back and put it in the structure that I specified. So my output fields are actually there in the object, and I'll show you that. You can see here that when I output the joke, I don't have to go, I don't know if you guys have done this, look at the OpenAI documentation and go, hold on a second, like how do I get the output again? It's like somewhere nested inside of like an array, and then it's like you get the first thing in the array, and then it's like, I think it's called output text now in the response. Yeah, you don't have to worry about any of that. Like, because I told it ahead of time that I have two output fields. Just one output field here, which is called joke. Then when I get the response back, I just go output.joke, which is really nice, right? Cool. So I told you need a data set. So DSPy, you can actually use the DSPy as a framework. You don't necessarily have to do optimization because it just formats that prompt quite nicely for you. Now you'll see an example of a DSPy prompt later on. The really nice thing is that you don't you could just use it without a data set, without an optimizer. You get a lot of the power from being able to optimize. Like the reason I pushed through all of the weird documentation and the structure and reading all this stuff and trying to understand the code base was because the optimizers can give you a reliable like 10 to 100% uplift in performance. So you're going to see that here today. So here I just got a bunch of from different locations. I got a bunch of funny jokes from different comedians, and that's just in an array. And then I have a bunch of unfunny jokes, and these are just generated by ChatGPT. Right? And all I've done is I've set them up in this kind of DSPy example thing here, and then split them into 3 buckets. So I have the training data, which is what I'm going to use to optimize on. I have the evaluation data, which is how it's going to test whether it did a good job in training. And then I have the development set, which is at the very end. Once I've built the model, I want to check that it does generalize to things it hasn't seen before. So that's why we have that held back. And then you can see here that we have 152 jokes here and then 51 to test against. And this is the format. I said before, how do you evaluate that? Like, how do you check, like, when you're doing DSPy optimization, it might call like a API 1,000 times. Like, are you really going to sit there manually and just say, yeah, that's a funny one, that's not a funny one, that's a funny one, that's kind of funny. That's really painful. So what we're going to do instead is we're going to train a judge to do that for us. So again, same structure, except we're going to input the topic of the joke and the joke itself, and then we're going to check whether it's funny or not. And I'm just using make signature here, and I'm calling this one audience. And you can see here our judge isn't very good yet, right? So why did the math book look sad? Because it had too many problems. Yeah, I mean, that is kind of funny. I did get a laugh, but like the judge said, this is a classic family-friendly pun that plays on the double meaning of problems, right? And they thought it was funny, and I said, no, that's not funny. That was in the unfunny group, right? So I want it to be a bit edgier than that. So that's what we've done. So you set up a metric. In this case, the metric is very easy. We have a data set of funny and not funny jokes. We know whether it was a 1 or a 0. So we literally just need to check if the program that we made in DSPy outputs the same as what we had in our data set. So if it was a 1, is it a 1? And you can see the result of that here. It got 47% accuracy. So, it's like a coin flip. It's not very good as a judge. So we need to train our judge. So you can see here, like, the ones that got wrong. These ones that got it correct, and then these ones that didn't get it correct. Like, it said false here, and it predicted true. Cool. So the optimization, everything we've done so far is literally just to get to this point to optimize it. So there's a few different types of optimization you can do. Broadly, they come into 2 buckets. One is that you add examples of the task being done correctly to the prompt. Few shot examples, it's called in the literature. And I haven't run a big optimizer here. I've literally just done this one, which is labeled few shot, where it literally just takes 8 examples from your data set and then just adds them into your prompt. And it formats them all in the right way as assistant and user, assistant as user, and user, right? So even just doing that, like literally that, took a second, and we got to 82% accuracy straight away, right? So you can see the power. Yeah, go ahead. Sorry.
8 examples in the...
Yeah, this is 8 examples, so k equals 8. So this literally just taken 8 examples, added them in. So you can see how quick that is. To literally just in DSPy, went from 50% to 80% quite quickly. Normally you'd have to write some custom code to add all those examples in and choose the examples. But the one that we're all here for, like the one that's really cool and sexy, is actually rewriting the instructions in the prompt, right? This is what prompt engineers do quite often, right? Like you'll rewrite the instructions, you'll see where it's going wrong, you'll look at the data and go, it's getting this wrong, it's getting that wrong, and then you'll write something manually, like in the prompt. Well, you don't have to do that anymore, which is nice. AI can do that pretty well, and it can look at thousands of examples in the time that it takes you to do one example. So it can iterate towards better instructions by trying out lots of different strategies. So this is the GEPA optimizer. It's the newest one. It's very cool. It's very good. I use it for everything now, and I've only run this with one kind of optimization loop. You could run it for 10, right? But it would take like an hour to do that and cost maybe like $10, $20, something like that. So it is, it's not cheap. I'm using GPT-5 here. I'm using a bigger model to train a smaller model. So I'm using GPT-5 mini to tell the jokes, but I'm using GPT-5 to teach GPT mini how to tell jokes, right? So once my optimization is done, I've invested that money and time. Now I can run my whole program on GPT mini, and it's like pretty good. So let's see how that works. You can see some of the prompts that it's writing here, and like look, this is like human level. So it's saying like it's giving some decision guidelines here, and this isn't me writing. This is just what DSPy has figured out. It's given some concrete examples here. It's given some instructions and rules. It said things like keep the reasoning tightly tied to joke structure. It's like basically written a guide on how to tell funny jokes, right? What is a funny joke? What isn't? Like I don't have a strong opinion on that. All I had to do is just choose which jokes I thought were funny and choose which jokes I thought were not funny, and then it has learned what my preferences are without me having to state my preferences, which makes building these applications a lot quicker. Cool. So you can see it's done a lot here, and then when it comes out the other end, now it's got 98% accuracy. It agrees with me, with my judgment, 98% of the time. right? Really, really good. We went from 50 to 80 and then to 98, right? And that's really powerful. And this took about half an hour. Actually, about 20 minutes, yeah.
How many examples did you use for this training?
Yeah, this one, yeah, so it's 51 to test, but it was just over 100 for training. Yeah.
It was all the training.
Yeah, and it chooses which ones to use in the training, so it hops around. It has like this crazy evolutionary algorithm behind it, written by people much smarter than me, but I get to benefit. Now we have a judge, and we have to make our new evaluation metric, but we can use the judge to do the evaluation. So we want to this time evaluate whether the joke is funny, and therefore we're using our optimized audience. Like this is the program that we trained before that has 98% agreement with me. Now I trust it to go and rate 1,000 examples on my behalf because it agrees with me 98% of the time. Perfect, right? So again, that's going to get the response, and then we're going to return whether it was funny or not. We're also going to return feedback because the way the GEPA algorithm works is it takes into account the structure of the program. It actually gets to look at the data set and see what it got wrong, but you can also give it feedback in the evaluation metric, and it will take that feedback into account as well. So in this case, I'm using the reasoning of the judge, like the judge thinks first before making the decision. I'm using that thinking process and then giving it like a look into the mind of the judge, and that makes it much quicker to be able to optimize and hill climb to a good outcome. Cool. So you can see here that we have the metric. If we look, it's got 100% accuracy. And then if we add, not 100% accuracy. So it's got 91% accuracy. What we've done is we've added, just like we did with the other one, we added some few shot examples to the comedian. So now the comedian has some examples of what is a good joke, what is a bad joke. And then we've run the same optimization process again with GEPA again, but this time on the comedian using the judge as the metric. And you can see we go through here. And now it tells jokes that are, it is like say 95% happy with. And you can look at some of these jokes. We're still seeing some errors, right? So we're still seeing one persistent thing we're seeing here is that it's saying, I can't write in this comedian's voice, but here's the joke. So that's, that's something we haven't specifically put into the evaluator. But that is like the next thing we would do. We would say, okay, if it says this, then give the feedback. Exactly. Yeah. So optimization again, it's not like a magic process, but I think it's pretty good. So let's just see. So this is telling a joke on AI engineering in the style of Ricky Gervais. And you can see it has this kind of refusal at the beginning, which we want to deal with. But AI engineering is teaching machines to be human, and it's gone too well. They now procrastinate, make excuses, and ask for a raise. Right? That's much funnier, right? I think. So cool. So yeah, hopefully that kind of helps you understand the process. Like it's an iterative process. I only optimize this for one turn. Normally I do say like 10 turns. But I just wanted to kind of help you understand how this structure works. Just one more thing, I'm going to just show you what the DSPy prompt looks like and how to export it and use it. And then we'll get Leo on and we'll do questions at the end, if that makes sense. Cool. So the DSPy prompts, they kind of hide them. Like they want you not to use the prompts afterwards. They want you to build the program in DSPy, which is something that like also put me off. Like I've been burned a lot of times with like LangChain and a few other frameworks, and like I built the first product in Llama Index, and then Llama Index wasn't cool anymore or whatever, So anyway, I keep going back and forth with frameworks. But one thing that's that like I would say like is a downside of DSPy is they kind of do make it a little bit harder to port your programs over. But I've now, because the optimizers are so powerful, I've now kind of moved over to like just doing everything in DSPy. So that's fair enough. But I do have a hack for getting the prompt out. So you can investigate here. You can see what the prompt is. You can see it wrote the input fields, etc. But then I have this like weird. I actually got this from the founder of DSPy because I was bugging him a lot, and he relented. But basically, this just outputs it in OpenAI format, right? So you could take this. This is a role system with the content, and then these are the few shot examples it's added. and then and then it has like the ending at the end. But just to kind of see the system prompt, just so you kind of get a sense here. This is what it's written, right? So it's already kind of, it's turned your signature into input fields. So all of that formatting stuff, it's all consistent. It's told that to like expect a topic, a comedian, a joke, and then it's using this weird structure that they use, but you can actually change that. You can change the chat adapters they use, but this does work pretty well out of the box. But the real power is this, like. You have a whole prompt here now. It says like you're writing a single funny joke given the topic, etc. The goal is deliver one concise original joke clearly tied to the topic. If the comedian is specified, evoke only high-level characteristics of their style. Do not imitate their exact voice. Keep it tight. 1 to 3 sentences with a clear setup and punchline. Make it feel fresh. Avoid stale, overused dad jokes. Like it's learned all of this stuff without me telling it. I didn't tell it I don't want dad jokes, right? I just gave it a bunch of dad jokes and marked them as 0. And that's really, really powerful. Now, if you think about taking that outside of joke telling, which is just a fun example, but like into other creative tasks, you now have the power to build a whole AI application where it can like learn your preferences, and all you have to do is just say, I like this one, I don't like this one. I like this one, I don't like this one. And then you have a data set. And yeah, there's a lot of complicated setup, but that's hopefully the takeaway is like, it's worth going through this to use a framework like DSPy, which I think is really slept on because of all of the weird documentation stuff, because now you can build a whole AI application where it writes itself. And you don't have to worry about writing those rules manually. You don't have to worry about what's conflicting or not conflicting because DSPy will figure that out for you. It will take it out if it's not improving the evaluation score. It will add something in if it is improving the evaluation score. So you can keep adding to your data set, keep retraining, and then you have like this kind of endless loop of improvement. So yeah, hopefully that will make sense. I'm going to be around afterwards as well for a bunch of questions. We'll do questions after Leo's talk though. And remember, there's like a free book if you ask a good question. So keep thinking. All right, thanks guys.